Salam, peace be upon you. My name is Muhammad Laif Sadipi, the father of Holophase, Part 50. Knowledge Systems as Long Lived 5-Pattern Infrastructures. How societies build, store, check, and transmit pattern knowledge across generations, and why maintenance matters as much as discovery. We began with one insight: pattern is primary. Phi is circular comparability, the root permission for distinction. Only relations are public. Identity is invariance under lawful transformation. Persistence is certified survival through change. Interaction is joint constraint. Time is ordered transformation. No ex nihilo. Every appearance has provenance. The observer is a pattern within pattern reality. Measurement produces traces. Memory stabilizes them. Models compress structure. Prediction narrows lawful futures. Learning updates structure while preserving identity. Intervention alters coupling. Computation transforms patterns under rules. Information is constraint on possibility. Publicness makes knowledge shareable. Scale determines what becomes visible. Coarse graining moves between scales with declared loss. Emergence reveals new patterns at new scales. Self-modeling turns patterns toward themselves. Meaning is functional usefulness for other patterns. Symbols are stable proxies that carry meaning. Interpretation maps symbols to what they stand for. Charity guides choice among interpretations. Language is the ecology where meaning lives. Now we ask, how does knowledge become durable across generations? The threshold we have reached. We have traveled far together. We have built a complete picture of what phi patterns are, how they relate, how they transform, and how they become meaningful. We have watched symbols emerge as stable proxies, interpretation as mapping between pattern families, charity as the discipline for choosing among multiple readings, and language as the ecology where meaning lives. Now we face the next great question. How does knowledge become more durable than one mind, one body, one moment, or one generation? A person remembers something. A family passes on a story. A village keeps seasonal knowledge. A culture records law. A library stores books. A university maintains methods. A laboratory archives measurements. A civilization creates institutions that decide what counts as evidence, what must be taught, what must be checked, and what may be forgotten. All of that belongs to the same question. This is the question of knowledge systems. A knowledge system is not just a pile of information. It is not only a bookshelf, database, curriculum, archive, or tradition. It is a coordinated pattern ecology that stores, transmits, checks, organizes, revises, and protects shared reconstruction across time. It is how language becomes durable public memory. It is how interpretation becomes institutionalized. It is how meaning becomes carried by stable practices rather than by isolated moments of insight. A simple, everyday example: the family recipe. Think of a family recipe passed down through generations. At first, it lives in one person's memory and hands. They know how much salt, how long to knead, what temperature to use. They teach it to their children. The children practice. They learn not just the words, but the feel of the dough, the smell when it's ready, the look of the perfect crust. The recipe is written down, but the writing alone is not enough. You need the embodied knowledge, the shared experience, the corrections over time. This is a miniature knowledge system. It includes storage, memory, written notes, embodied skill. Retrieval, Calling up the recipe when needed. Check in. Does the bread turn out right? If not, adjust. Transmission. Teaching the next generation. Revision. Adapting to new ovens, new ingredients. Who decides what counts as the real recipe? The recipe survives not because it is written in stone, but because it lives in an ecology of practices, memories, and relationships. What knowledge systems are? Let us define knowledge systems clearly. A knowledge system is a coordinated ecology of records, memory practices, interpretive conventions, validation mechanisms, transmission pathways, maintenance structures, and governance rules that enable patterned reconstruction to persist across time and community. This means a knowledge system does at least six things. Storage. Knowledge does not survive unless traces are stabilized somewhere. That somewhere may be a brain, a song, a ritual, a clay tablet, a law code, a hard drive, a scientific archive, or a social custom. Storage means that pattern structure is held in a form that can later be re entered into reconstruction. Retrieval. Stored patterns must be brought back into use. A library catalog, a teacher's lesson, a database query, a search engine, a memory queue, these enable retrieval. Without retrieval, storage is just hoarding. Check-in. Knowledge systems are not mere containers. They are also filters, tests, and correction machines. They assess claims through replication, calibration, peer review, cross-checking, apprenticeships, public trials, audits. Without checking, storage becomes rumor. Transmission. Knowledge must pass from one mind, group, or generation to another. Teaching, writing, demonstration, instruction, imitation, these are transmission pathways. Without transmission, knowledge dies with its carrier. Revision. No living knowledge system can remain wholly static. New evidence appears, contexts change, terms drift, errors are found. Revision is not betrayal of knowledge, it is survival. But revision must be traceable or continuity collapses. Governance. Knowledge systems always involve rules, norms, institutions, and power relations that decide how storage, retrieval, checking, transmission, and revision are organized. Who gets to write the archive? Whose testimony counts? Which languages are standardized? Who has access? These are governance questions. An example across scales, the scientific discipline. Consider a scientific discipline across generations. Young students are introduced through textbooks and lectures. They learn terms, symbols, standard models, classic experiments. This is transmission. They enter laboratories where tacit practices become visible. How instruments are really calibrated, how data is cleaned, where uncertainties hide. This is embodied knowledge, part of storage and transmission that no textbook fully captures. Papers and datasets are stored in archives. This is storage. Researchers retrieve them through journals, databases, libraries. This is retrieval. New results undergo peer review, replication attempts, community discussion. This is checking. When errors are found, when new evidence appears, theories are revised. Old models are updated or replaced. This is revision. Funding agencies, journals, universities, and professional societies set standards, decide what gets published, who gets promoted, which research is pursued. This is governance. The scientific discipline is not just a collection of facts. It is a living ecology of practices, institutions, and relationships. Without this system, the facts alone would not sustain a science. Another example, the legal system. A legal system is a knowledge system. Storage. Laws are written in codes, recorded in precedents, stored in archives. Retrieval. Lawyers and judges access these records, cite precedents, interpret statutes. Checking. Courts test claims against evidence, appeals review decisions. Law schools teach future lawyers. Opinions are published. Traditions are passed down. Legislatures amend laws. Courts overturn precedents. Constitutions evolve. Who makes laws? Who interprets them? Who has access to justice? The law lives not in any single document, but in the whole ecology of practices, institutions, and interpretations. Knowledge systems are not omniscient. Here is a crucial point. Every knowledge system has fidelity limits. No transmission is perfect. No archive captures everything. No institution is unbiased. No memory is complete. No translation is lossless. No curriculum includes all relevant knowledge. No model preserves all features of the world. This means knowledge systems are not omniscient mirrors. They are finite, patterned infrastructures with access regimes, losses, and blind spots. A map helps travelers but leaves out smells, weather, insects, and local stories. A legal code preserves rules but leaves out much lived nuance. A textbook compresses a field but omits failed paths, forgotten traditions, and tacit skills. A machine-readable database may preserve values while losing the texture of lived meaning. So every knowledge system must carry humility about what it leaves out. At the same time, omission is not always failure. Without compression, no large-scale knowledge system could function. The issue is not whether anything is omitted. It is whether omission is declared, accountable, and suited to scope. Here we hear again the echo of coarse graining. Declared loss is honest. Hidden loss is smuggling. 7. Translation between knowledge systems. Knowledge often moves between different systems. A craft tradition becomes a manual. Oral stories become written texts. Indigenous knowledge becomes scientific data. Local practices become global standards. Every translation changes something. It preserves some invariants and loses others. A skilled craft may be badly translated into a manual. The feel of the clay, the timing of the gesture, the judgment of when it's right, these may not survive. A ritual may be flattened by outsider description. Its meaning, its context, its embodied significance may be lost. An indigenous weather knowledge system may be dismissed because it does not appear in the dominant archival form, even though it has sustained communities for centuries. So, strong knowledge systems need translation discipline. They must ask, what is preserved? What is lost? What context is dropped? What tacit skill must be transmitted by apprenticeship rather than document alone? What does this form make visible? What does it hide? Without that discipline, knowledge systems can become engines of erasure while believing themselves to be preserving truth. 8. Knowledge systems and power. We must also look directly at the relation between knowledge systems and power. Who is believed? Who gets archived? Which dialect becomes standard? Which discoveries are cited? Which failures are erased? Which communities are treated as knowers and which merely as sources of raw material? Which traditions are called superstition and which are called science? Which languages get keyboards, schools, and publishing? Which bodies are trained to interpret and which are forced merely to obey? These questions are not external politics added after the fact. They are part of how knowledge systems actually work in the world. A science of knowledge systems that ignores power becomes naive and blind. But acknowledging power does not mean collapsing knowledge into power. That would be another mistake. The point is not that truth is nothing but authority. The point is that public access to truth is always mediated by systems that can be shaped, distorted, democratized, corrupted, repaired, or opened. The mature position is this: knowledge systems are neither pure mirrors nor mere power games. They are patterned ecologies in which reality, interpretation, institution, and governance continuously interact. Maintenance as moral epistemic task. Here is one of the deepest insights of Part 50. Maintenance is not secondary. It is one of the deepest moral and epistemic tasks of knowledge systems. Who repairs the archive? Who updates the index? Who teaches the next generation? Who preserves endangered languages? Who digitizes fragile manuscripts? Who checks whether measurements drifted? Who stores negative results? Who notices when convention changes? Who prevents the server from failing? Who remembers what the symbols meant? These are not merely administrative questions. They are pattern survival questions. A civilization may produce brilliant discoveries, but if it neglects the systems that maintain them, those discoveries will fade. Libraries burn, languages die, skills vanish, institutions collapse. Knowledge is not self-preserving. It requires care. A formula for knowledge systems. We can compress the architecture with a simple schema. K equals F, S, R, C, T, V, G. We pronounce it: a knowledge system is a function of storage, retrieval, checking, transmission, revision, and governance, where S equals storage, stabilized traces. R equals retrieval, bringing back into use. C equals checking, validation and correction. T equals transmission, passing across minds and generations. V equals revision, adaptation without loss of continuity. G equals governance, rules, norms, power relations. This is not a strict numerical law. It is a structural map. It reminds us that what we call a knowledge system depends on all these interacting components, not on any one alone. If storage exists without retrieval, knowledge slips. If retrieval exists without checking, rumor spreads. If transmission exists without revision, error multiplies. If governance exists without publicness, power hardens into dogma. If revision exists without continuity, memory shatters. If continuity exists without revision, the system fossilizes. Ecological balance matters. 11. The rigor layer, the knowledge system gate. Knowledge systems get their own gate, the knowledge system gate. The knowledge system gate asks, is there an identifiable storage layer? Is there a retrievable pathway? Is there a checking or validation mechanism? Is there a transmission ecology? Is there a revision process? Is governance visible? Are drift and loss acknowledged? Are fidelity limits declared? If the answer is no, if components are missing, if governance is hidden, if loss is ignored, the knowledge system claim cannot be certified. The knowledge system gate requires storage declaration, where and how patterns are held. Retrieval specification, how patterns are accessed. Checking mechanism, how claims are validated. Transmission pathway, how knowledge moves. Revision process, how adaptation occurs. Governance visibility. Who decides? Who has access? Fidelity limits. What is lost? What is omitted? Drift acknowledgement. How change is tracked. 12. Firewalls. What knowledge system discipline blocks? Knowledge system discipline installs several critical firewalls. Firewall 1. No treating knowledge as self-preserving. Knowledge requires active maintenance. Firewall 2. No reducing knowledge systems to data piles. Storage without retrieval, checking, transmission is not a system. Firewall 3. No imagining archives without interpretation are sufficient. Records need readers. Firewall 4. No confusing authority with validation. Prestige is not proof. No treating one storage medium as exhaustive. Knowledge lives in multiple forms. No forgetting embodied and oral components. Tacit knowledge matters. No pretending revision is betrayal. Adaptation is survival. No hiding governance behind false neutrality. Power is always present. These firewalls keep knowledge system claims honest. 13. Refusal conditions. We refuse to certify a knowledge system claim if storage layer is unspecified, retrieval pathway is absent, checking mechanism is missing, transmission is not addressed, revision process is ignored, governance is hidden, fidelity limits are undeclared, drift is not acknowledged. Refusal here is not pedantry, it is protecting the integrity of our understanding of how knowledge lives. 14. Why this matters. Beyond science, knowledge in civilization. Knowledge systems are not only for science, they are for how civilizations survive. A society that does not maintain its knowledge systems loses its past, its capacity to learn, its ability to coordinate. It becomes vulnerable to manipulation, to forgetting, to repeating errors. A society that understands knowledge systems as living ecologies, requiring storage, retrieval, checking, transmission, revision, and governance, can build more resilient institutions. It can protect what matters. It can adapt without losing continuity. This is not an abstract concern. It is a matter of survival. Libraries burn, languages die, skills vanish, institutions crumble. Knowledge that took generations to build can disappear in a generation of neglect. Maintenance is not secondary. It is civilization's most important task. A final image: the library and the librarian. Imagine a great library. It contains thousands of books, manuscripts, maps, the accumulated knowledge of centuries. But the library has no librarian. No one organizes the shelves. No one repairs damaged books. No one updates the catalog. No one teaches new readers how to find what they need. Over time, the library becomes unusable. Books fall into disrepair. The catalog becomes outdated. New generations cannot find the knowledge they seek. The books are still there, but the knowledge system has collapsed. The librarian is not an accessory. The librarian is part of the system, maintaining, organizing, teaching, preserving. Knowledge systems require keepers. 16. Closing insight. We began with comparability. From phi emerged distinction. From distinction emerged pattern. From pattern emerge identity, persistence, interaction, measurement, memory, modeling, prediction, learning, intervention, computation, information, publicness, scale, coarse graining, emergence, self-modeling, meaning, symbols, interpretation, charity, language. And now, knowledge systems. Knowledge systems are the long lived infrastructures of shared pattern memory. They are coordinated ecologies of storage, retrieval, check in, transmission, revision, and governance. They have fidelity limits. They require translation discipline. They are shaped by power. They need maintenance. Knowledge is not only something we discover, it is something we must keep alive. We now move forward. With knowledge systems understood, we can ask, how do these systems fail? How do error, distortion, and breakdown enter? And how do we repair them? That is part 51. Always, peace be upon you.